whenever I give these tours, people often ask whether or not it makes sense to do solar in Vancouver. And when they ask that, I usually ask which country generates the largest percentage of its electricity from solar. Germany. If we installed the same system in Germany, it would actually produce less electricity than it does here, at least in most of Germany, not all of Germany. So it's not really our weather or climate that's the issue. We don't see a lot of solar here because we have cheap energy prices. There are different types of solar energy systems. This is the one that produces electricity, or it's also called a photovoltaic system. So it's not using heat. In fact, it's more efficient in cooler temperatures. So the way it generates electricity is the photovoltaic effect. I like to ask who first discovered that effect and what prize he won for doing so.
Einstein.
Einstein, and the prize he won?
Nobel Prize.
Nobel Prize, yeah. So Einstein won the Nobel Prize in physics for explaining the photovoltaic effect, which I can't explain as well as he can, but basically you have two layers in a semiconductor material. A photon of light hits the two layers, causes an electron to jump. You attach electrodes, you capture that electron, and you have electricity. This is our straight grid tie system. So the building's still connected to BC Hydro, so they're now getting power from two sources, from the panels and from BC Hydro. The panels get priority, so the electricity from the panels gets used in the buildings first. If it's not producing enough electricity, they can still get the electricity from BC Hydro. If it's producing too much electricity, they can actually feed the excess onto the grid and get a credit from BC Hydro. So there's no batteries, that's what I was going to say next. No batteries, no storage, it's just a straight grid tie system. There are 90 solar panels, so you can see 15 right there behind us. There's another 15 over here that's a little bit hard to see. And then there's 30 on each side of here, so 90 panels altogether. The panels produce DC or direct current electricity, but what type of electricity do we use in our buildings? AC, right. So you need to convert the DC to AC. This particular system uses microinverters, so there's actually little boxes up on the roofs that convert the DC to AC. You can't really see any from here. Over in that corner, if you look up, you can see there's little silver boxes on the back of the panels that are the microinverters. These microinverters are actually three-phase inverters, for those of you who are concerned about the more technical information. And I think this installation was the first one in Canada to use three-phase microinverters. They're relatively new. From there, the electricity goes down to the breaker panel, and it just gets fed in to all of the electrical systems in the building. This particular solar energy system is just tied to the common areas. So like this building here, the underground parking, all the common areas, not the individual suites. They have their own meter, and this is just going to the meter for the common areas. It's a 23 kilowatt system, that's the nominal rating for it. Here in Vancouver, it will generate about 25,000 kilowatt hours a year. That's enough to offset 2.5 average households in British Columbia. I would say the average household is not very energy efficient. Our 4-person household, it would power about 10 of them. So, some households even more that are more efficient than that. I think that's all the basic information, but if you have any questions, let me know.